So when I say, so our topic will be today, okay. So when I ask you, what do you mean by neuron? What you will say?
Carries messages from the brain to
Messages from the
the
brain.
body.
So how does it looks if I draw it?
Yeah.
Right? It looks something like this. Right? So this is nothing but my cell body. This is my axon. These are my something I'm not understanding. I forgot. These are our synaptic buttons, and these are our dendrites. Right?
Yeah.
And this is our nucleus. So what it does, it tries to take the messages from here and then pass on. Right?
Yeah.
So what it tries to do, if I say my neuron is this, messages are coming, it will try to remember something and then pass on, right? For example, this is a ball, this is an apple, right? Both are kind of a round, but certain features are there which are different. So these are things my each neuron tries to identify. If you see the human neuronal system, then human neuronal system is very complex. Not only it tries to find or sees what the things are and tries to differentiates. It has many other things, right? Trying to see how the body is functioning, what kind of temperature it is outside, what I am hearing, what I am tasting, what I am sensing, and so on. There are many other things which the medical researchers have not even found out, right? So many things are there. Maybe I'm in my deep conscious state, I'm thinking something depending upon what is happening in this particular time. Sometimes something is happening miles away, but I'll be getting a sense of it. Okay, something is happening, I'm not feeling easy, right? There are birds and animals who will even know what kind of natural disaster is going to come, and they will be something uneasy behavior they will see. You will see, right? So many things are there, right? So what is neural network then?
Yeah.
Right? Am I correct? So what is neural network? Neural network is the computational representation of your biological neurons or your biological behavior. Okay, what you do biologically or what animals are doing, that you will be trying to replicate in computational. Okay, so what it will look. Okay, how it will look, that will be the first question. Okay, let me tell you. This is a picture. This is a picture of a human body, human face. Right? This is a picture of a human face. Now, when I am looking at the picture, I will look like this. But when my camera or I will try to transfer it to computer, it will not be like this. it will be something divided into this. Right. And each small unit is known as pixel. Right?
Yeah.
Pixel. So what does pixel values says? Pixel values tries to capture a value from 0 to 255. Right? If 0 is my complete black, then 255 is my complete white. Okay.
Yeah.
Right. So what it tries to say now, if I tries to let me only for pixel, right? I will try to represent this as right. So let me divide into four pixels. This is my 255. This is my 255. This is my 255. And this is my 0. Or else, let me represent in a very simple way 0 to 1. Right? So this will look like this. Right? In indirect way, your computer will look into this as like this. Right? So this is your kind of a image processing. How we are looking into the image. Same thing when I'm trying to send something, I'm hearing something. Let me say I'm hearing a signal, a sound, a music. So music, when I try, that is a music, right? So this is my sound box. A music is coming. When I try to acquisize it or try to look as it in the computer, when I try to read it, it will look like this.
Yeah.
Right? So this is how I'm representing my data. So this is how my data is looking. Okay. So then how does this neural network come into the picture and everything? Neural network, even your artificial intelligence is a kind of a mimicking of your biological, form. What your biological form is doing, let me say what your human body or animals are doing, we're trying to replicate them in the computational form. How the wolves are catching the prey, how I'm looking at the universe, or how I'm looking at my surroundings, how I am sensing my surroundings, what I'm getting to learn from my surroundings, everything I'm trying to replicate from the biological thing, and I'm going for okay. So that is how my artificial intelligence system says or speaks. And my neural network is a kind of mimicking my nervous system, mostly my nervous system. Okay. Any doubt?
No.
Okay. So so now you understood that neural networks is trying to mimicking your nervous system. Okay. So in my nervous system, my building block of my nervous system is my neurons, right?
Yeah.
So when I showed you that biological neuron, now how my computational neuron will look like? Okay, so let me take an example and get. Right, this is my AND gate. So my features are, this is my feature, this is my output, right? So this is my training example 1, this is my training example 2, this is my training example 3, this is my training example 4. Okay, so how it will look like? So what I'm trying to do, this is my input, I will sum it, I'll pass to some function, this is my output in an overall broad sense, right? But when I try to go inside this and see, this will look like this. Okay, this is my activation function. Getting it?
Yeah.
So now, why I did this? So when, for example, this is what? This is my input is coming. Okay, so when this one is coming, 0 and 0, my input will be 0 and 0. Okay, the same way, what you learned in linear regression and logistic regression, how the weights will be assigned and everything, it will also follow the same rule, but a different kinds of representation. Okay, why this representation is different, you will come to know in the later stage. So this is our neural network which will look, right? So again I'll draw it, so we will try to deduce it. Okay, so if you see, all the arrows are pointing in this direction, right? So this is my feed forward network. Okay, feed forward network, I'm feeding it here, my input I'm feeding it here, and it is taking me forward. Okay, so here in this case, we have, as we are saying, we will see our AND gate. Now, if I plot my AND gate, how it will look? So when it is 0 and 0, this is my x1, this is my x2, and 0 and 0, it is my 0. Okay, so this is my 0. When it is 0, x1 is 0 and x2 is 1, this is again 0. When my x1 is 1 and my x2 is 0, this is again 0. And when my x1 is 1 and x2 is 1, it is 1. Okay, so now if I try to divide it, so these are all my zeros, these are all my zeros, and this is my 1. So definitely, according to when you learned your linear regression or logistic regression, this is your hyperplane, right? So what is the equation of the hyperplane? Hyperplane will look like this: h theta x is equals to, or hwx, because I'm telling this one is w. Theta and w, I'm trying it same. Okay, or in the better sense, I'll say w. Hwx will look like intercept. This is my intercept plus w1 x1 plus w2 x2 and some error will be there, let's say. As of now, I will not take the error, right? So this is my equation of this hyperplane. Now, how I deduced from this particular example? Now, when I see this one, let us go like this. What this one will look like? This one will say W1x1 plus W2x2 plus bias is there, W0 into bias, right? That is how your till your summation will look like. Now then what is your output? Output is nothing but this again multiplication of f into summation is equals to f into W0 bias plus W1x1 plus W2x2, right? So mostly your bias is represented as, let's say, I'll give it as 1. So how it is? W0 plus W1x1 plus W2x2. Because I'm trying to have this bias, all the information in W0 only. Okay. So it will look like this. In other sense, it will look like this. Right?
Yeah.
Now each output is learned like the linear regression. Each output, how it will look? Output I. Then what I will add over here? I'll add as I. For all I is equals to 1 to m. Okay.
All right.
Now you got the sense of neural networks. How this neural network is happening? We'll go into deeper how the deeper neural networks are happening. So just some history about how it tries to, what your courses are saying. Neural network, when they originated, the algorithms tried to mimic the brain. What your brain is thinking, what your brain is doing, they try to mimic your brain. It was very widely used in 80s and 90s, and most popularly in the late of 90s got diminished. There are some problems due to which it got diminished. Okay. Now again it has evolved. It has evolved in a more advanced way. How we will look, how I am sensing, all those minute details we are trying to capture right now in our neural networks. So this advancement of neural network is your deep neural networks. Okay. Okay, advancement of the neural networks. Even your other original, these all neural networks are there. But deep neural network is an advancement of your artificial neural networks. So this whole thing which I'm talking about is the simple neural networks. Advancement of the neural network is the deep neural network, right? So just think about it. When we are now we are thinking about our complete brain, right?
Yeah.
So this is my brain. Right, so this brain has many different things. This section will be mainly for hearing. This section is mainly for visualization. This section is for taste. This section is for sleep, and so on. Right, so there are each different units or each different parts of the brain that are responsible for their own characteristics function, right? But think about you. Are you distinguishing between all the things that you're doing? Irrelevant of what you are doing, your brain tries to capture it. Right now, let me say you are looking at the your one match, cricket match you're looking. Let me just give it. You're looking into one match, right? But it's not like that. I'm just not looking into it, but many different other things also I'm doing it, right? Right, this match is going on. Now see here, what I am trying to do, I am looking at England batting, I am looking at Sri Lanka's batting, I am looking at the scorecard. I'm not looking at it, but my brain is doing it automatically in my subconscious mind, right?
Yeah.
Looking at the background, your crowd, how they're looking, this field, it is automatically I'm identifying the colors, different colors I'm identifying this scorecard, I'm identifying what are the different kinds of objects, right? So many different things I'm looking at the same time, right? So think about how the complexity it will be, right? How complex it is.
Yeah.
But everything I'm doing at the same time, I'm not distinguishing between what I am looking at, what are the different kinds of things I'm visualizing, or different kinds of objects I'm looking. But no, I'm looking at one thing, my eyes are only looking, but my brain is trying to differentiate. So how these differentiates came into the picture? So these differentiates came into the picture by different learnings. Learning 1, learning 2, learning 3, learning 4, and so on. Now you will ask how this learning came into the picture. These are very difficult, right?
Yeah.
I just show you a simple neural network. Let me say like this. This is my input. The same, what I'm looking, my eyes are looking, that is the same thing. And this is my output, right? And in between, the summation was happening, the function was there, and it was coming. So indirectly, I can represent this as like this. Right?
Yeah.
Now let me put some more. Same thing. Same thing. So think about the linkages, how the linkages are happening, right? Now, if I cut my neurons and I show you each neuron will be connected to many other neurons, right? Similarly, same thing. This is one of my neuron. This is one of my neuron. This is one of my neuron. I know it will be confusing right now, right? You are getting confused, right? You are able to understand?
Yeah.
Okay. So what I try to see, the different kinds of connection, interconnection, connection I try to represent. Okay. So let me now tell you. So when a problem comes, I have to identify. Now see, my brain is doing a lot of things at the similar time. Let me go into only one thing. I will try to identify human beings. Okay. So how it will happen? This is my input layer. This is my output layer. What I want to know is output. Let me say over here only two things, apple and balls. Okay. These are nothing but my hidden layers. So how this is representing computationally and biologically? This is you are looking, your eyes taking the data. What is this? Identifying. Are you knowing what is your brain doing? No, right?
Yeah.
See, this is your brain, right? So how this connection will happen? Let me take your for apple and balls. Your data will be shape, size, and color, and kind. Kind will be apple. Shape will be round. Size will be oval. Color will be red. Then it will be round, circle, green apple, right? Then it will be round, your size will be threaded, this will be yellow ball, and so on, right? Let me say this is my data. So what your eyes are trying to identify, your eye is trying to identify what kind of shape it is, what kind of size it is, and what kind of color it is, right? Using these three, it is trying to identify what kind it is, right? So now when I put it everything, this is my shape, this is my size, and this is my color, right? And then what is my kind, right? So this is my input, and this is my output, and this is my hidden layer. So now you have understood that there are three layers. One is your input layer, which we call as input. This is my output layer, which we call as output, and this is my hidden layers, right? So now we will try to understand how our hidden layers are looking. Okay. Now when I say this is my, now you don't know, right, how many connections are there in your brain. That is completely hidden to us.
Yeah.
Right? Let me say I'll put my hidden layers at like this. First hidden neuron. Okay. So what happens? Right?
Yeah.
This will give me one output. Okay.
Yeah.
Now another hidden layer will be there. Right? So how this one will look? This one also again same connections. Right? And this is my output. So what it was, as I told you, this is my x1 color, sorry, shape, this is my size, this is my color, right? And the data will be coming like this. As I now try to remember what your building block or the simplest neural network look. Okay,
Yeah.
let's try to remember. So this is nothing but the same, this one I will take, right? So when I take this one, how it will look? So this orange one, what I can represent? I can represent as hidden neuron 1 and hidden neuron 2, right? So let me just take this hidden neuron, how this hidden neuron will look like. So this hidden neuron will look like this. Right?
Yeah.
And let me say this is my bias, or this is my W0. This is one. This is my W1, W2, and W3. Right?
Yeah.
Right? And this is hidden layer 1. So this complete thing that we are doing, that is for our hidden layer 1. When it is hidden layer 1, I can put it, right? Right? So how this output, now this output is nothing but the output is here, this output, my neuron output, okay, output of 1. So now if you see, this one will be, output will be f of summation j is equals to 0 to 3 w j k x I j, right? Why I took k? You'll be asking, you'll be thinking, this k is nothing for my hidden layers. What is this j? This j is nothing for my number of neurons. 1, 2, 3. Now
What's
I
what's
is
k?
yeah, tell me.
What's k again?
Okay. I, j, and k I have taken. I is same training examples, right? Because you will be learning from a training examples. J is for my number of features. K is the number of hidden layers. Oh, sorry, hidden neurons. Now if you see, I have done only one hidden layer, right? And in one hidden layers, one hidden neuron computation is happening like this. Same thing will happen for H2 also. Now I have got my H1 and H2. Let me say I've got one H1 and H2. This is again now connected to another neuron, which is giving my output. Now how this one will look? Let me say this one as if I say this one as W1, this will be W2, right? So if this one was for my K, this will be for my L.
Yeah.
Right? So that, now think, one neuron, this is one neuron, it is going into second neuron over here. Now once these two neurons are connected, this is my third neuron. So how many neurons are there? 1, 2, 3. Total 3 neurons. And that happened, only one hidden layer it is there. This is only one hidden layer. Okay. So now when we go deeper, how it will look? The same thing. This is my shape. This is my size. This is my color. Once this is done, let me say this is my hidden layer 1. 4 neurons. Let me say this is my hidden layer 2. And let me say this is my output. Right?
Yeah.
Right? So now how this whole connection will look like? This connection will look like this. Right? So let me say this is my W1. Whatever weights my this layer is learning, and this layer is learning. Okay. Let me say this layer weight is W1. Same thing for my this layer. Let me say this is my W2. For my output layer, this will be nothing but I'll say this is my W3 and this is my output. Okay.
Yeah.
This whole connection will be completely fully connected. Right? Now see about this one. This is my W1, right? This is my W1, this layer.
Yeah.
W1. Now it is going from hidden layer 1. This is hidden layer 2. It's going from first to this one. So what I wrote, I wrote is WIJK, right?
Yeah.
So this one will be my 1 1. This is my 2 1. This is my 3 1. This is my 4 1. So all the blue colored this one blue color lines. Okay. So one is your W111, second one is W121, third is W131, then W141. Same. That's why. So these are 4. This is W11. Sorry, think about these colors. Okay. So let me say this one. Only this one will take. Okay. I'm going to say this one you take, right? So how it is coming? W11, W21, W31, right?
Yeah.
Now take about, okay, take this one. Okay, how it will, now this is hidden layer 1, but neuron 1, so that's why we wrote it as 1, and the same thing will happen. W12, W22, W32, right?
Yeah.
Now take about this one. Same thing. It will be W13, W123, W33. Now when we go for the last one, how it will be? W14, W24, W34. Right? So how my weight 1 vector look, right? Weight 1 vector is looking like this. W11, W12, W13, W14, W21, W31, W22, W32, W23, W33, W24, W34, right? The analogy. So we told W1 and let's say J and K, right? So K is varying from 1 to 4 and J is varying from 1 to 3. So how you understood? So these are, J is nothing but number of features and K is for number of hidden neuron which this one is connecting, right?
Yeah.
Right. Now you understood how this W1 is looking like. Let's go to W2. How it will look? Same thing. It will also follow the same principle. Sorry.
So are there only 2 layers, like
No, there can be many
till
layers.
W3 or?
Many layers. 1 layer, 2 layer, 3 layer, 4 layer, 5 layer, 6 or 10. Many layers can it be. But think how much computation it will be. Right? Hello? Hello?
Yeah.
Right? So think about the computation, how many computation it will be. It will be very expensive computation, right? So now see this one again. Right? See this one. So for W2, see this neuron. How this one will look like? This will be your W. Let me say this is hidden layer 1, hidden layer 2, hidden neuron 3, hidden neuron 4. This is hidden neuron 1, hidden neuron 2, hidden neuron 3, hidden neuron 4. In hidden layer 1, let it be hidden neuron 1, hidden neuron 2, hidden neuron 3, hidden neuron 4 in hidden layer 2, right? So how my this connection will look like? This connection will look like this: W1 1, W2 1, W3 1, W4 1, right? The same thing when I go to this 2 1, sorry 1 2, 2 2, 3 2, 4 2. When I go to this, it will be 1 3, 2 3, 3 3, 4 3. When I go to this, how it will be 1 4, 2 4, 3 4, 4 4. So my second neuron looks like this. I wait for the second, right? So you understood? So this happened for the second neuron hidden there. Now we have one more. Our output is also there. Now how my output will look? Right? So it's only one neuron. So think about this. Right? So this is nothing but my beta 1, beta 2, beta 3, beta 4, or I'll not write beta, but I'll write in the W3. W3 1 O, this is my output. W3 2 O, W3 3 O, W3 4 O, right?
Yeah.
Right? So you understood, right, how this one is happening. So if I say this is X, right, this is my X, so how this one will be looking like? This one will be something X is equals to, or my this whole, this is nothing but my matrix output, right? Let me say Y1, hidden layer 1, will be W transpose, W1 or W1, I write it here, transpose into X. Some functions will be there, right?
How is it transpose? Like, how did you get that? W1 is equal.
For simplicity, I will do 3. This is my 2. Think about hidden layer 1. So hidden layer 1 1, hidden layer 1 2. Okay. So this is my x1, x2, x3, and this one will be my. So let me say I will write in this one as x1, x2, x3. Okay. So this is 3 cross 1. Now my x, this is my h11, h12. This is my 2 cross 1, right? So how many weights are there? Now weight 1 is equals to okay, this one is for W11, W21, W31, and another one is W12, W22, W32. So this is 3 cross 2, right? So how I will write this one over here so that I get 2 cross 1. I'm trying to make you understand. Okay, different people, different books will try to give you a different analogy, but try to understand what is happening inside it. Right? So how your H11 and H12 is coming. So if you see, definitely they are getting summed over here, and there is one function. This is giving an output. This function is nothing but we can start with sigmoid function. Okay, kind of giving a non-linearity. Sigmoid function is there. Okay. This can be 1 also. This can be your tan function, tan inverse function also. This can be many kind of different functions. I'll tell you later. In a later stage, we'll try to have one activation function class. So this is happening, right? So right now, if I write my W in this manner, then my H11 and H12 will be nothing but W into X, right? W11, W12, W21, W22, W31, and W32 into X1. Sorry. Yeah. So if I write my W in like this, then it should be WTX. Then it will become 2 cross 3. Right?
Okay, yeah.
Right? So if I write this, some people will be telling you W1 can be W11, W21, W31 for my hidden layer 1, W12, W22, W32. They can be writing this. But you don't try to by heart. Try to understand what is happening, how the calculation is happening. Okay.
Yeah.
So now you understood how it is happening. So if I write H11 and H21, this will be something as F into W1TX, right?
Yeah.
Now why I have taken this F outside? Because I have assumed if I say like this and I try to maximize it, right? I have assumed this F to be same for this neuron also and this neuron also. That is sigmoid.
Yeah.
There can be a situation people will be using different neurons. Here one neuron, here two neuron, another sigmoid, okay, or another activation function. So that can be. And one more assumption I have taken, this bias was usual one, right? I have taken neglected for simple showing and making you understand. But this bias will also be there. It will be something 0, 1. Because we have taken bias all the information in the weights. But I'm not using it just for simple understanding. Okay.
Okay.
Now you got it. So this is happening. For that reason, I have taken this one as complete function outside. Okay. Now when we add this bias term, then this bias term will be written over here as B. You will see people are writing as B. So there are different kinds of analogy how people use it, but I try to make it use in this W only. Okay. But the functions are same. Everything is same. You just have to understand how it is happening inside. Okay. So I don't want you to completely by heart. So now you understood what is happening, how this computation H11 happened.
Yeah.
The same thing when we go to the output. Output will be nothing but F of W2T into H. Sorry, this is for my hidden layer 1, right? One hidden layer. Now for the second hidden layer, it will be same. H, let's say 1, 2, H22. It will be same thing. F, W2, T. Instead of X here, you will write it this. Let me say this is my H1. Write it as H1. Okay. Now when we go for output, output will be nothing but F. I've written W3 transpose into H2, right?
Yeah.
But now see, H2 is also a function of some W. When I write it, how it will look? H2 is H1, right?
Yeah.
But H1 is also something. What is H1? Right? Right? Okay.
Yeah.
I will not go deeper, you will get confused. Okay, so let's do one thing. You try to find, I'll give this as a question. Try to have two hidden neurons, two hidden layers. The input you are having 3 neurons. Okay, in hidden layer 1 there are 4 neurons. Take the bias also into the effect. Hidden layer 2, you have 2 neurons. Take the bias and 1 output. Here also take the bias. Okay, so this is my second question. Question number 2. Question number 1. Draw the biological neuron and artificial neuron. In this, find the mathematical output. And for question number 3, in question number 2, here just you have to draw it, okay? Draw. In question number 2, find the mathematical output and each output of the neurons. Okay, so this is your 3 marks. This is your 2 marks. This is my 5 marks. Okay. Hello.